Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com.
And kubelet is like an embassy in a country, right? If this is India, for example, and this is Sri Lanka, and this is USA, for example, then if there is an instruction to be executed on those countries, you have an embassy in every country, right? Embassy is like an agent that is running on behalf of your country. So if the foreign minister or minister of external affairs says, all right, we need this to be done, then the instruction goes to the embassy, and the embassy then executes the task, right? Similarly, the scheduler instructs the kubelet, right? And the kubelet knows how to run containers and how to run pods. Okay, so this instruction actually to run 3 pods will go to kubelet, and then kubelet will immediately run 3 pods. And the kubelet here will get instruction to run 2 pods. It will immediately start running 2 pods. Yeah. Now, once this is done, well, API server also keeps an eye on the state of your cluster. Otherwise, how will it know that 1 pod is missing or 1 node is down, right? So that state is stored in something called a key value data store called as etcd. So it stores the cluster state in etcd data store. All right, and that CD data store contains, like, how many pods are running, where is each pod running, how long a pod has been running for. Every aspect of the cluster is stored in etcd database. Okay, now there is also one more component that is called as controller manager. Now what does it do? So let's say a request was given for 5 replicas. It went to API server. API server instructed scheduler that here run 5 pods. Now 1 pod dies, right? 1 pod dies. Then what happens? Immediately this embassy will say there is something wrong here. 1 pod is missing, and gives this information back to the API server that 1 pod is missing. Do something about it. And API server says, all right, looks like 1 pod is missing, and it updates the etcd database. Right? Now this controller manager is responsible for maintaining the state of this cluster. Okay, it also regularly talks to the etcd database and says, all right, looks like there are only 4 pods running, and looks like the request was for 5 pods. There is a mismatch. Okay, so the controller will immediately realize that there is a mismatch here, and it will again talk to scheduler and will say, all right, you need to run 1 more pod. Okay, then scheduler will say, all right, let me run 1 more pod. Let me talk to this embassy and start 1 more pod here. Okay, now API server, etcd, scheduler, kubelet, all are event-based components. some input comes and then they generate some activity or they do some activity. So the developer says deploy application, API server does something. And then when the API server says run pods, scheduler does something. When scheduler says do something, kubelet will do something, right? So it's all event driven. But this controller manager is a loop. It's a always running loop. All right, so it will always, maybe every 5 seconds or every 10 seconds or 15 seconds, which is a configurable unit of time, it every n number of seconds, it will keep an eye, it will check the state of the cluster and will do something if there's a inconsistency in the cluster. Okay, so controller manager always runs in a loop. Other components are all event based. All right, so these are the components that are in play when you use Kubernetes cluster. There is one more component. Let's call it as it's called as kube proxy. Okay, there's a component called kube proxy. So what does kube proxy do? Well, kube proxy enables this communication between multiple nodes. Okay, from here to here, from here to here, from here to here, this communication also is possible. And this proxy enables this communication, right? All this communication is authenticated and encrypted, right? And it's very difficult for each component to know, how to authenticate and how to work with different components. So what proxy does is it stores all the certificates which enable this authentication and encryption, and then kubelet, instead of talking directly to the API server, how I showed before, which was incorrect actually, which was architecturally correct but technically incorrect. What kubelet does is it talks to the proxy and says, hey, via proxy, I would like to talk to API server and say that one pod is down.
Hey viewers, our Master in DevOps engineering program can help you to hone the skills necessary to succeed in high-level DevOps positions. So, what are you waiting for? Enroll now and earn certification that show you are keeping pace with today's technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Kube scheduler via proxy will talk to kubelet. Okay, so proxy enables this communication, this encrypted communication. Make sense how this cluster works? Any questions on this? If you understand this, you have already conquered around 40% of Kubernetes. Open for questions.
Hello, Amit.
Mm-hmm.
Yeah, so now if a pod is down, kubelet informs API server, right? And
Yes.
API server stores it in ECD, and it is the controller that initiates the creation of new pod, is it? As in the controller detects it, and again it informs API server to create a new pod, is it?
Yes.
Okay, okay.
So the controller manager actually does not talk directly to the scheduler. Controller manager says run a new pod, and then API
Okay,
server will say, okay, hey scheduler, run a new pod.
okay. Yeah, thank you.
Okay, question from Anupam is what are the controller manager and API server called on OpenShift? So everything remains same. When you have a commercial offering of Kubernetes, for example, all the internal components remain the same, right? What those distributions do is they build on top of it, right? So for example, if I just remove this one here. Right, so this is pure vanilla Kubernetes architecture. Now, if you have OpenShift, for example, then they would also add a nice GUI. They will give you a nice GUI here, right? There is also very limited user management on Kubernetes, so you get much better user management or authentication and authorization. Hmm. Then you also get some extra features. For example, you can build your images. You get your own container registry. So you don't have to rely on Docker Hub. You can get your own private container registry when you use OpenShift, right? So these are some features which are added. Otherwise, internally, it all remains the same. So we will set up a cluster now. I will set up a 3-node cluster. One will be master and 2 will be worker nodes. Now my master machine would be a bit high powered. That means 2 cores and 4 gigs of RAM. So I'll use 2 and 4 here, T2 medium. Yeah, so this is my master. I'll just name it as one. I'll call it as master. Okay, and let's create 2 more instances for worker nodes. And they can be T2 micro. So I want 2 instances here. Everything remains same. We want to open the traffic. Yeah, so let's call it as node 1. Node 2. All right. So now we have 3 nodes and we are going to create a cluster. So we'll pull them in a cluster, all of them. So first thing, or one thing which is essential for the cluster to work is that Docker should be installed on all the cluster nodes, including the master node. So I'm going to install Docker on all of them. So I'm going to connect to all these nodes first. Let's connect here as well. For the nodes, I'll just make the color as white. Yeah. These are my nodes and this is my master.
Hey viewers, trying to get into DevSecOps? Enroll for our DevSecOps certified professional programs and earn the certification that shows you are fit for these technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Amit,
Okay.
I just have a quick question on I think you just repeated just a quick AWS question is that how many CPUs and RAM would be needed for the master and the workers if we were trying to provision it ourselves just
So there is no minimum set by Kubernetes, but a recommended minimum is 2 cores and 4 gigs, or 2 cores and 2 gigs. Yeah. If you have anything less than 2 cores and 2 gigs of memory, then um, uh, when you start deploying your cluster, you get a warning or you get an error that not enough resources are available, but you can always ignore those and move ahead. But the minimum that is recommended by Kubernetes is 2 cores and 2 GB of RAM. But again, it all ends up on how many resources you want to run, right? If you are planning to run hundreds of containers on your cluster, then definitely you have to plan according to that.
Okay,
So it's all. Mhm.
Okay, and okay, yeah, that makes sorry to interrupt. So that makes sense. So, but what if like you're getting on to, like to those sort of like Google or Amazon's AKS and stuff? Do they already provision it for you?
So when you use EKS, for example, what EKS does is it just gives you a master, right, or a managed cluster head, control plane, a master, right? You have to bring your own nodes and attach to the cluster. So then again, it's up to you what kind of nodes you want to attach to the cluster.
Okay, thank you. That makes sense.
Okay, so first things first, apt update on all the machines. Well, that's an AWS thing. We always need to do an apt update here. And then I would say apt install docker.io. That's it. Yes, please. Oh, no. Yes. Yes. So I'm installing Docker on all the places. Docker is installed here, right? Now we have to install some binaries which can help us in bootstrapping our cluster. Okay, so let's talk about those binaries. Well, there are 3 main tools involved in managing and your cluster working. So first tool, let me choose a better color here. Yeah, first tool is called kubeadm. Now this tool will be used by the administrators to manage the cluster. So it will be used to bootstrap the cluster, right? Upgrade the cluster. It will be also used to manage the nodes of the cluster. So all admin low level tasks like the operating system level and the cluster level tasks are done here. Then you have something called as kubelet, which we already know. Kubelet is the agent that runs on each machine. So we have to install that. And then there is another tool called kubectl. Kubectl is short for kube control, and this is the tool which can interact with your cluster. So it's a client for your Kubernetes cluster. So from wherever you want to access the cluster via command line, you have to have the kubectl. Okay, so what I'm going to do is now I will install all these 3 tools on all the machines. Okay, now these tools are not available in standard repositories, in standard AWS repositories. So we have to add those repositories for apt. All right, now how do we do that? Well, we can just quickly go to Kubernetes Bootstrap. So if you search for Kubernetes Bootstrap, you will get this documentation. Go to installing kubeadm, and here is the complete installation guide. Okay, so all these things are not required here in our AWS setup, but we start from here, installing the runtime. So we can install Docker or any other Kubernetes or container runtime like CRI or Rocket Ship or whatever, or containerd. Okay, then we have to install kubeadm, kubelet, and kubectl. So for all Ubuntu or Debian based systems, we will follow Debian based distribution guide. For CentOS or Red Hat, we can follow these commands, or manually we can download each binary and then install them. Okay, all right. So we go with Ubuntu, and it's just as good as copying these commands. All right, so I'm going to copy this command here and just dump it on all the machines. Well, we already did apt update, so the second apt update was not really required. But yeah, it gets all the required tools which will help us add the repository. Right now we get the GPG key, which enables us to have the secure connection with the repository. There you go, on all the machines. And then we add the apt repository here. Added, 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 right? Now let's do an apt update. And when we do an apt update, you will see that packages.cloud.google.com and Kubernetes release are also now added here, right? So packages from here will also be available to install, and that's where kubeadm, kubectl, and kubelet lives. All right, so now I'm going to run this command on all the machines, apt update, and then install kubeadm and kubectl. We will not mark hold it because it's not a production instance, but yeah, we'll just run these. So I'll just go ahead and run these commands on all the machines.
Hey viewers, are you looking for formal training on SRE practices? Take our SRE program. This course will teach you how to successfully implement site reliability engineering in the modern day 24/7 services. Kickstart your SRE training today. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
What does mark hold mean?
Well, mark hold will fix the version of these tools to whatever is installed. So if you install kubeadm and it installs, for example, version 1.0, then if you do apt-get upgrade or apt-upgrade kubeadm, it will not allow it because you have frozen that version on this machine. So unintended upgrades of these tools will not be done.
Okay, that makes sense.
All right, we have our kubeadm, kubectl, and kubelet on all the machines, right? So first thing that we should know is as soon as you install kubelet, it runs as a service on all the machines. So if I say systemctl status kubelet, you will see that it is activating. So it is installed, right? So kubelet is installed. Okay. And kubeadm is also available now, and kubectl is also available now. So that will be the case on all the machines here. Kubeadm, kubectl, and kubelet are all available. Next thing, let's bootstrap the cluster. So we don't need to configure the driver, and let's go to the next step, which is bootstrapping the cluster here. Now here you can see the requirements, right? At least 2 GB of RAM, at least 2 cores on the control plane, right, on the master. So, but this is not very tightly enforced. You can skip this as well. But I have seen that 2 GB and 2 CPU actually is required. Otherwise, your machines get stuck. Okay, now what do? We'll just do initialization of our cluster, which is this. Okay, and there are other parameters that we have to pass, that we may pass to this kubeadm init, right? For example, if you are running multiple or a load balanced master, then we use control plane endpoint. If we are um, installing a custom network, which I will talk about later, we will use pod network CIDR, then customization, container runtime interface port, and things like that. There are a lot of things. Okay, but right now what we are going to do is we are just going to take the default kubeadm init and just let our cluster come up. Okay, so I'll run this kubeadm init command on our master only. So it is now going to download all these components that we discussed: API server, controller manager, scheduler, HCD, proxy. It will download all these components and run on itself. Okay, so it says pulling images required for setting up a Kubernetes cluster. So all these components that I just showed to you, these components, they also will run as pods, right? So all these components will run as pods and they will do what they have to do. And done. Our Kubernetes cluster is done. Let me maybe make it a bit bigger here. Kubernetes cluster is done. And as soon as Kubernetes cluster is done, it gives us some helpful commands here. Well, there are two commands. First is this one. So to talk to your cluster via kubectl, you need to know the default user that you need to talk to the cluster as, and also how to authenticate. Right, so all that information is available in this admin.conf. You want to connect to your cluster as admin right now for us in our demonstration. So we will copy this configuration file which contains complete access information and keep it in our home directory. Okay, so just run this command and we are good. All right, now our kubectl is able to interact with the cluster. We say kubectl get nodes, for example. This is a command which will show the complete information about the nodes. And if I press enter here, it will show me that there is one node added already here. This is one node, status is not ready. We'll come to that. And this node is control plane or master. So this node is this machine itself. You can make out with the host name. Right? And now I think it's a good time to add the other nodes as part of our cluster. So there are two other nodes which we have to add to the cluster. Now, as part of your kubeadm init output, you would also get a join command here. This command can be used to join any of the nodes to the cluster. So I'm going to copy this command and run it on all our nodes. What does it say? Invalid discovery token. Okay, so I think, did I copy everything correctly? Token, hash is this. Okay, see, actually the output is in multiple lines. I did not copy the third line. But now the output is split, so I need to actually It should be like this. So if it was running on full screen, the output would have come nicely, but here it has got split. So that's okay. I just fixed it, and I'm going to execute this command everywhere, and it will pull some Docker images to build or to run some activities, and also it will start the kubelet service with proper credentials. Right, kube, and let's say systemctl status kubelet, and you see our kubelet service is now up here, and it is just talking to our master. And on the master, if I say kubelet kubectl get nodes, it's going to show us all the 3 nodes.
Thanks for watching. Want to study further? Join our training programs today.